Hello and welcome back. Now, in this segment, we're going to start talking about motion. And you can see in this picture here, these people are not very happy to hear that I've just said that. But formulas are not necessarily as scary as what you might think. Formulas are necessary because, for one thing, it cuts down on the amount of writing that you have to do. So let's take, for example, speed. And speed and velocity are different concepts. They're related, but they're not quite the same. But for you, we're just going to say that speed and velocity are the same thing. So what do I mean when I say that something has a certain speed? Okay, so the definition of speed then is, I'll say that speed is the rate at which the distance changes as time changes. Now, how would you like to have to write that down over and over and over again? Okay, so let's see if we can simplify this a little bit. So instead of the word speed, let's use a letter. So just one letter to represent speed, and we're going to say V, as in velocity. Okay, so velocity is the rate at which distance, okay, so let's get rid of all of this. So instead of the word is, let's put in an equal sign, and then we can get rid of this. And instead of the word distance, let's put the letter R. So I'm going to use the letter R for distance. Okay, and then the distance changes as time changes. So we'll put time, T for time. Okay, so now we can get rid of all of this stuff here. And then there is our formula for speed. So we're going to say that the average speed of an object is the distance it travels in a certain amount of time. So distance per unit time, that's going to be speed. So it takes up a lot less room on your piece of paper, and if you have another formula, you can sometimes substitute that formula into this formula. So that's the advantages of formulas. And now we can actually put numbers instead of the letters for there. Okay, so let's go to our next slide here. And there's our formula for speed. So linear distance, distance is going to be the letter R. And the official metric unit for distance is going to be the meter. And so a meter is about this big. Okay, so it's about the size of a yardstick, but a meter is a little bit bigger than a yard. So that is the official unit that is used in science when you're measuring distances. So notice that there's two letters there. I've got the letter that represents the concept, R. So R represents linear distance. And then M is the letter that represents meters. So sometimes that can be confusing. So what I tend to do is I will put the letter that represents the concept in parentheses, and then the letter that represents the unit, I'll put it in brackets. I don't know if that helped or not, but that's the way that I like to do it. So to help you to understand a little bit more about what speed means, think about your speedometer. So in your car, or if you've been in a car, you've seen the speedometer. What are the units for speed on your speedometer? So if you're going down the highway, you're traveling at 60 miles per hour. So exactly what does miles per hour mean? Okay, so it would be miles per hour. So it's the number of miles you travel in 1 hour if you were going at that constant speed. So look at this. You've got a distance divided by a time. Just like up here, you got a distance divided by time. So really, you've been doing this all along when you're driving your car and you're looking at your speedometer. You're looking at your speed. And I bet you've even done calculations, like for example, if you're going at 50 miles per hour and you travel for 1 hour, how far do you go? Well, you go 50 miles. Well, what about if you go 2 miles or 2 hours? How far do you go? Well, you're going to be able to go for twice that, so you're going to be able to go 100 miles. So you've been doing stuff like this all along in your head, but you may have never seen a formula that goes with it. So here is a math problem. If an object is traveling at 20 meters, it travels for 20 meters in 5 seconds, how fast was it going? So whenever you do a word problem, always write down what you're given and what you're looking for. So it says up there 20 meters. So I'm going to write down 20 m, and then I'm going to write down 5 seconds, and then I abbreviate the word seconds with the letter S. And now I say to myself, meters was a unit of what? It was a unit of distance, okay? And then what was my special letter that represented distance? That was the letter R up here. And then the letter that represents seconds, that's time, and so that's the letter T. And then what am I looking for? How fast was it going? So that's the speed. I'm looking for the speed, and that's the letter V. And I just put a question mark next to it. Then I say to myself, do I have a formula that combines V, R, and T? And here it is, up here. So I write down my formula, I plug in my numbers, I get out my calculator, and so 20 divided by 5 is 4, but don't leave it like that. Don't just say the number 4, because if you gave that problem to somebody else, they would say 4 bananas. Okay, they're not going to know what the 4 means. So we're going to put units on it. So let's look. If the unit for distance is the meter and the unit for time is the second, then the unit for speed has to be meters per second. Okay, so that's the concept of speed. You have to know that because we're going to be talking about rockets and things that are moving, and we need to know how fast that they're moving. Okay, we're going to take a break, and when we come back, we're going to talk about acceleration.